Have you ever wondered how much a shadow weighs? It may sound like a paradox or a riddle, but scientists can weigh shadows. Now, you may argue, a shadow is just an absence of light. How can it weigh anything at all? To answer this question, we need to delve into the intriguing physics of light. Let's start at the beginning. What's a shadow? Simply put, a shadow is a dark area where light from a light source is blocked by an opaque object. But here's where it gets interesting. Light is composed of particles called photons. These photons, even though they are incredibly minute, exert slight pressure when they hit objects. This is called radiation pressure, and it is a result of every photon carrying a tiny bit of momentum. Now, how does this tie into our original question? How does this explain the weight of a shadow? If photons carry momentum and impart slight pressure when they hit objects, then an absence of photons, a shadow, will cause a slight decrease in this pressure. Following this logic, when an object is in shadow, it is, in a very, very minuscule way, lighter than when it is in light. But here's the kicker. The weight difference created by shadows is so insignificant, it's practically immeasurable. We are talking about a decrease in weight that's less than a billionth of the weight of a postage stamp. Stay with me as we dive into even more fascinating aspects about shadows and the unusual phenomena they present. Now, let's explore the fascinating relationship between shadows and gravity. We know that objects with mass create gravity, but what about photons? Do they also experience the gravitational pull? According to Einstein's theory of general relativity, even massless particles like photons are affected by gravity. So, when a photon travels near a massive object, its path is bent due to the gravitational field. This means that in the presence of a massive object, like Earth or any other celestial body, shadows can also be influenced by gravity, causing their shape and weight to vary. However, these changes in shadow weight caused by gravity are incredibly minuscule and practically undetectable. To put it into perspective, imagine measuring the weight of a shadow caused by a person standing on Earth compared to the weight of the same shadow caused by that person standing on the moon. The weight difference between those two shadows is less than 1/billionth of an ounce. Even though the effects of gravity on shadow weight may seem negligible, they still exist and contribute to the complex relationship between light, shadows, and the cosmos. Now, let's explore another intriguing aspect of shadows related to quantum physics. In the quantum realm, particles like photons exhibit both wave-like and particle-like properties. This duality is exemplified by the famous double-slit experiment, where a single photon can behave as if it went through both slits simultaneously. When this double-slit experiment is conducted with light, it creates an interference pattern of bright and dark regions known as a diffraction pattern. In the presence of obstacles or opaque objects, these diffraction patterns can be transformed into intricate shadow patterns. These shadow patterns provide valuable insights into the wave-like nature of light in the fascinating world of quantum physics. In conclusion, shadows may seem like mere absences of light, but they hold profound secrets within the realms of physics, gravity, and quantum mechanics. Join us in the next part of this captivating journey as we delve even deeper into the mysteries and peculiarities of shadows and their weight. Welcome back to our exploration of shadows. We left off with the complexities of shadow weight and the influences of gravity. Now let's shift our focus to a different aspect of shadows, their role in optical illusions. Optical illusions are intriguing phenomena where our eyes perceive something that contradicts reality. Shadows play a crucial role in creating optical illusions by manipulating our perception of depth, shape, and orientation. One famous example is the cafe wall illusion, where alternating black and white tiles create a distorted sense of slanted lines. Shadows cast by these slanted lines enhance the illusion, further tricking our brains into perceiving a skewed reality. By understanding how shadows intertwine with optical illusions, we unravel yet another layer of their mesmerizing nature.